3, 2, 1.
Check it out.
All right, mic check, 1 2 1 2. Yo, what's up, everybody, and welcome back to Real Talk with your boy MD. All right, look, today we're just gonna get straight into it. But before I do, just gotta say something first. I owe you guys a bit of an apology. You know, a while back, I promised I was gonna open source MDX, put the code out there, let people dig in, and I just haven't done it yet. Look, I'm not going to give you a long excuse, but here's just the reality of what's happening. Right now, I'm just moving too fast, like way too fast, and everything's kind of just like wired up as one organism, and to actually open source this thing properly, I'd have to literally stop, untangle things, set up separate repos, and that's kind of like weeks of momentum I genuinely just can't give up right now. So I'm making the call, speed over promise, and look, I'll own that. But all I want you to know is it is coming. I'll get to it at some point. And in the meantime, I'm going to keep doing exactly what I've been doing. So I'm going to keep sharing everything I'm learning through these videos, through the publications on the website. So at least the knowledge that I'm getting, it stays open, even while the code is catching up. So just give me a bit more time, bear with me. And while I'm confessing things, the code base has also gotten a little out of hand. So when I first started, it was like, Python and mostly vanilla JavaScript, because I didn't need all the opinionated frameworks. It was pretty clean and simple. And now it's like there's Python, still vanilla JS, Rust has shown up, React has kind of crept in, and has become like a polyglot now. So, I mean, look, each product brought the right tool for the job. And I'll explain why Rust showed up a little bit later, and hopefully it'll make sense, but that's just kind of the state of where things are. All right, so today is going to be a bit of a rapid fire update because so much has happened since my last video. They're trying to give you guys a proper deep dive into everything would turn this into an hour-long episode. And I don't think you want that. I don't even know if I want that. So it's not what we're going to do today. Instead, I'm going to move quick, tease 5 things, and drop a couple of new publications on the website where you can go and get, the full depth of anything I cover here. So think of this as kind of like a trailer, and the publications are like the movie. All right, so you may be wondering what are the things we're going to cover. There's 5 things, okay? The first thing we're going to do is take a quick look at the OS, because I keep saying that word, and I don't know if everyone's kind of understands what I mean by it. So let's make that feel a little bit more real. We're going to talk about something called Forge, which nobody's heard of yet. There's a couple of apps I threw together just overnight at one point. MDX Code has also gone through a closed loop experiment that I'm currently running. Exciting stuff. And there's something called MDX Message. It's going to make some of you go, wait, what? What is he even doing? All right, so with that, let's get into it. Okay, so MDX OS, let's actually take a look at it. And so here's the console, mission control. Every component is kind of checking in. You can see the status of things. And okay, so just a quick reframe before I really start walking through some of these screens. Like when people hear an operating system, you might picture Mac OS or Windows or something that you boot into, and that's okay, right? Because there is an analogy with that, but I have a different mental model for how I think about this, okay? Almost all companies have what I would call a human operating system. It's kind of invisible infrastructure that everything runs on, everything from how people get hired, how you onboard, how you form teams, how you navigate, how work flows across the organization, how decisions get made, the meetings that you're attending, how you set goals, what objectives you're shooting for, things like that, the culture of how people show up on a day-to-day basis. All of that stuff, that is like what I would call the human operating system for a company, right? And all of these organizations so far were designed with humans at the central core. I mean, that's just how we've grown up. This is what's been the reality over many decades. So as I was looking at this and where we are with the state of AI and agentic, what would it look like to build a company from scratch with no humans in it, just AI? And what would the operating system for that look like? And so if you start from that viewpoint, you would probably set up infrastructure and these different components from a very different way. And so anyways, that is like the mental model I had when I was thinking about the operating system. And so as you look across the screens that I'm showing right now, there's there's a component registry of like 15 components across 3 layers. Right, this foundational layer that handles model abstraction, so you're not locked into like one provider. It could do things like knowledge, context, memory, observability. There's many things. The orchestration layer is where agents spin up and coordinate. And then there's the interface layer, like the APIs and the console, right? And this is the thing I love. Right now, you can see every agent that's been invoked, token consumption by component, every routing decision made under the hood. And so observability, being able to track what's happening, measure things across the system is super, super critical. So observability as a first-class citizen from day one, not bolted on after the fact, that was like non-negotiable. Okay, and so that's the OS. Next up, we got Forge. Okay, so Forge sharing this publicly for the first time right now. So once the OS existed, I was thinking that although the 15 components are there are a bunch of primitives. And you can't really build fast on top of those. So there's almost this gap that appears between the primitives and the apps or use cases that you could build on top, okay? And that's where Forge comes in. So Forge is kind of like the engine that sits on top of the OS, right? Is that layer between the OS and anything you want to build. And what it does is its main role is to abstract the complexity. It makes the primitives composable. So whether the developer is using it as a human or an agent, it doesn't matter. And the analogy I'd have for Forge, the way to think about it is it's kind of like WebKit. So you've never really opened WebKit or you don't really think about WebKit. But without it, there's no browser. That's how modern browsers like Chrome or Safari, they're both based on the WebKit engine. And that's what makes it run. So Forge is kind of like that. And so I will be dropping very, very soon after this video. I'm going to drop a full publication that gives you a deep dive on the genesis of Forge, why, what it does, and what it's trying to solve. But right now, all I need you to know is it exists. It's on top of the OS. And the reason I'm mentioning it right now is because I'm going to get into like the next part, which is only possible because of having the OS and then the Forge layer on top. Okay, so once the OS and Forge are both there, I wanted to test how fast I could really go, right? And quick disclaimer, what I'm about to tell you is just me experimenting, okay? This has nothing to do with Sun Life or where I'm at. It's me experimenting, trying things in the open. And so I was, one night I had an idea. I started thinking about it around 8 p.m. Then I started working on it like 5 in the morning the next day. And I wired up a bunch of stuff with like fake data. So this is not official work for anything. And so I started working with like fake data, mocking up, fake endpoints. So this is not related. This is not real at work in any way. So quick disclaimer, what I'm about to tell you is just literally me experimenting at a personal level. Okay. This has nothing to do with what's happening in Sun Life or anything like that. It's me having ideas, wanting to work with this tech. But I was like, hey, what could I do? Applying the stuff that I've built to public organizational stuff that's out there. And so I took a use case where I said, you know what? I'm going to make an agent called Stella, right? It's an agentic wellness and benefits coaching concept. It's a riff on ideas that are already public out there. Sun Life has something called Ella. So I'm like, all right, let me take that up a notch. What would that look like if I put the latest tech in it? So 2 hours later, from idea to something running and being interactive, that's all it took. There's 20 minutes of actual coding happening within there. The rest of it was me thinking, designing, and architect, okay? But the reason I was able to go so fast was because all the hard problems were already solved. The model routing, the knowledge layer, the context management, I didn't have to solve any of that. All I had to do was describe the application, okay? So after that was done, I'm like, yo, can I push this thing even further? What if I layered in Apple Watch or Apple Health biometric data? What would that look like? And then could I integrate that with some of the stuff that Stella was doing in that first prototype? And I called this one Pulse. So 45 minutes later, yes, that's all it took for this one. From idea to running on my stack to where we can access it now, that it's up and it's running. And look, the point here isn't really about Stella or Pulse or any of those things. The point I want you to take away from this is compounding, right? So you invest in the foundation once, and everything after that, it gets cheaper. So the OS, building that, it wasn't a tax. It's a force multiplier. And Forge just accelerates another order of magnitude on top of that. And now I'm able to get all the benefits as I want to start building and executing use cases against it. All right, on to the next one. And next up is a quick update on MDX Code. And look, MDX Code has probably gone through internally with me at least 6 different divergent paths. Okay, so I've been all over the spectrum solving different things in different ways. So apologies that if the MDX code public repo that's out there, is quite dated. It's very niche, but I've gone through a whole bunch of different versions in the last 65 days. But, all of these experiments, they're starting to come together. And the main thing I was trying to figure out was like, why am I the glue in between all of this coding stuff that I'm doing? Okay. So all the different tools out there, Cursor, Copilot, all of them, the AI, so all the AI coding tools on the market right now, like Cursor, Copilot, all of them, the AI is basically focused on accelerating the human. So me in this case, while the human stays the engine. So you describe what you want, it writes code, you review it, you deploy it. There's this collaborative partnership that's happened. And so all the things I've been learning so far and the things that have been able to just get faster and faster and better as the models are advancing, the thing I kept asking myself is like, the AI can write the code, it can also test results, it can handle some failures, and it can ship some outcomes. Why am I playing this like copy pasting orchestrated type of role between different terminal windows that I have? And by the way, I've ditched the IDE at this point. I don't even use the IDE, and there's reasons for that. And I'll talk about it in the publication. But like right now, I'm in between terminals, and I'm playing this like human network router between all the different things, right? So with all of that, the models are very capable. The role I'm playing is the orchestration. And so I was trying to figure out if there's a way for me to go from intent to basically deployed software without me having to thread the needle. And that's what I called phase 18, internal terminology. And my goal was to try and close the loop, okay? So basically, it's like trying to make a black box SDLC. Intent comes in. There's a whole build pipeline and an execution pipeline within there where, it creates a plan. It creates, it reviews the plan, executes in parallel waves. It handles its own failures. So self-healing, self-learning. Right? It auto finalizes and consolidates things, and then it gets ready to get out. I did have 2 human touch points. So the first is after you give it the intent and it creates the plan, you can have a quick, approve or deny. It's pretty binary right now on the plan. Okay. And the other one is before it actually ships into production. Okay. It lets me handle the merge. And that's a conscious choice. I could have automated that part, and lets me make any SQL migration changes that I need to put, right? So those are the only 2 things I'm doing is reviewing plan and that final merge and SQL updates at the end. Everything in between those 2 points is all machine. And look, just to be clear, this is still an experiment. It's not hardened. I'm not handing it to a team tomorrow or anything like that. But for me, the loop closed. And that was the main question I was really trying to answer for myself. There's a lot of hard learning that was happening within there, right? Like I was able to get the majority of the initial pipeline working, but the hardest part was literally integrating. And then there was like real failures happening with how processes were spawning and dying, real terminal sessions, and they were sometimes leaving like stale branches or Git work trees, and then those weren't merging properly, and like a whole bunch of like failure mode trial and error that I kind of went through. But after heavy experimentation with a happy path scenario of a very small project, I'm happy to say it works. And now I'll have to work through like edge cases and try and give it some real project work that I'm currently doing myself. But anyways, with all that to say, I do believe we're on a path from intent to production with no human in the middle. I think that's just where things are going. So the question isn't whether that's doable. The question is, I think there's a different question, is how do you design safety mechanisms that make this trustworthy? And then, the answer for that isn't like having humans review things harder, because there's no way humans are going to be able to keep up with the amount of code being generated. And so I think what we'll have to look at is like, how do we make safety structural rather than procedural? How do you have governance gates, Sentinel contracts, item potency guarantees, and all of that wired in? So anyways, I have a whole thought piece around this on the website. Check it out. The architecture, the thesis, what broke, what I learned. Go take a look. There's way more depth that's covered there than I can do justice in this video, but just wanted to share that experiment with you. All right, now we're on to the last one, and this one, I hope it lands like a doozy, because I had no idea I was going to end up building this. The idea came, it made a ton of sense after I thought about it, but we're here to talk now about MDX Message. So you might be thinking like, why does this guy need another messaging app? We have so many messaging apps out there. Why build your own? All right, so just bear with me for a minute, just stick with me. So Slack, I love Slack, big Slack user for many, many, many years. Slack was built back in like around like 2013. So way before, ChatGPT or Claude, or before anybody imagined that AI would ship production code through like a conversational thread, right? So the assumption for a long time baked into every enterprise messaging tool that exists like right now is that humans talk to humans. And if an AI shows up, well, it gets like a bot badge or a sidebar widget, an integration or a webhook or something like that. So it's like bolted on, right? And so in these messaging platforms, AI or agents are never really first class participants. And all of this assumption is like over 12 years old. And I'd like to say that, based on where we are right now, I think it's breaking. So as I was building MDX and all the different components, and I got agents spinning up, doing work, handing off things from one agent to another one's escalating to me as a human. I'm giving feedback. There's a whole bunch of communication that's happening, but it's happening in different pockets. Some of it's invisible. It's in logs. It's in different areas. Some are buried in webhooks. And then, when you're trying to solve something that breaks in production, it's like you're trying to stitch all of it together. So as I looked at that, I wanted a place where an agent and human are on the same thread or on the same plane for when it comes to communication. And a system shouldn't care about which one it came from. Did it come from a human? Did it come from an agent? Did it come from something else? Right? It just routes the message, delivers it, it persists, it logs it. So the thinking really here was agents as first-class participants, not integrations. The same as any human. And the mode that changes everything is agent to agent. When MDX code kicks off a review agent, that agent hands off to a security scanner. The scanner escalates to a human. That entire chain flows through the message bus. It's observable, it's debuggable, and it's auditable. Right now, we're used to human pace. A few messages a minute. Agent to agent won't look like that. It's going to be orders of magnitude faster, denser, chattier. And if you can't see it, can't observe it, what your agents are saying to each other, then you lose the ability to trust your own system, especially as we're working towards what I call that closed loop development model. And then just to kind of get to like what I teased earlier, why did Rust show up? Well, Rust showed up because I needed to handle real-time relaying in high throughput situations. So the real-time relay for MDX message is written in Rust on Tokyo because you can't afford garbage collection pauses when messages need to arrive in sub 20 milliseconds. Okay, and I looked at patterns out there. Discord made the same call, same reasoning. They've got a strong communication platform out there. And I decided to just like bite the bullet at the beginning and get it in rather than refactor later. And so the way to think about MDX message is not really a standalone product. It's a communication primitive at the OS layer, right? So MDX code, MDX twin, the CI pipelines, they all talk through the same fabric, right? I call it the stream fabric, same transport, same delivery contract, and all the audit trail. But then there is an application powered by Forge that lets you see that interface. And that's what you're seeing on the screen right now. As you can see on the screen that I just pulled up, you can see what that communication looks like, coming in from an agent. Then it has code blocks that you can see. Then the pipeline jumps in. I'm communicating at the beginning to give intent. Then I go ahead and give a response at the end. This is basically the starting of the flow and the problem space I was trying to solve is like, as we have these processes between humans and agents, how can we create as much transparency as to what's happening and have it organized in a clean way that we can make sense of it, and then we build a historical trail of this. And again, imagine the recursive learning loops and context engineering as a result of. All right, so that was probably a lot to absorb in a small amount of time. And like I said, there's plenty of publications on the website you could check. Forge is coming soon. But everything I walked you through is not a collection of separate products, even though I called them individual products. I'd look at it as a stack, and the stack is compounding, and that is the big deal. Okay, so the OS gives me primitives, Forge gives me the engine. And once those two exist, things like Stella and Pulse, they're literally 2 hours or less, or 45 minutes. And then building a messaging system in literally just a weekend. And then phase 18, it gave me the closed loop, going from intent to production with 2 human checkpoints, which I could theoretically just remove. So message gave agents a communication layer they actually deserve. And look, with all of this, I just want to let you know, I'm just getting warmed up. So I see the through line. It's clear to me. I see where this is going. I don't know if most people are ready for it, but all I gotta say is keep building, keep experimenting, and keep sharing what you learn, and I'll keep doing the same. And so with that, this one's a wrap. It's been a real talk. Enjoy your week. Peace.